Hello, in this video we will be talking about logic networks. Imagine that the electrical voltage carries along wires fall into two ranges, high or low, which we will represent by 1 and 0 respectively. Voltage fluctuations within this range are ignored, so we are forcing a discrete, which is a binary indeed, that masks on an analog phenomenon. Also, suppose that a switch can be wired so that a signal of 1 causes the switch to close and signal of 0 will cause this switch to be open. And combine two such switches controlled by X1 and X2, which are two parallel lines. So in this figure, we illustrate the circuit acts like OR, the disjunction in propositional logic. So when you have the gates both closed, meaning x1 is 1, x2 is 1, so true or true will give me true, and false and true gives me true. And as you know, true and false also true, and two false gives me false. But you could think about it as when the gate is closed, so the electricity will go through. At least one of them is closed, with still electricity go through, so you're still gonna have a 1. But when they both open, the electricity is 0. So this OR gate, where we're gonna see here, behave like the plus in Boolean operation, and the AND gate represent the Boolean operation that, which is AND. So as I said in previous videos, plus is OR, that is an AND. So here we are. The OR gate we represent it this way, and the AND gate this way, and then the negation gate. And here is the truth tables for this Boolean expression x1 plus x2, which is similar to the logic or truth table when you have A and B, and then you have A or B or A naught. So here is the definition of Boolean expression. So for example, here I have x3, x1 plus x2 naught x3. These are all Boolean expressions and examples of Boolean expressions. So sometimes we omit the dot symbol and we just put them together like this one here. In propositional logic, the logical connectives, so this AND, OR, and negation are instances of the operation of Boolean algebra, as I was saying before. So this is a dot, a plus, and negation. So truth functions, where is the truth function for Boolean expression? So Boolean function, truth function is a function f. It goes from 0 and 1. It depends how many x1 to xn. If you have x1 is xn, you're going to have as many zeros and ones. The output is always 0 or 1 for some integers n greater than 1. So these notation 0, 1 to the n denote the set of n tuples of zeros and ones. So for example, this here we have x1, x2, x3. So we're gonna have 3 tuples, x1, x2, x3. And then to do the truth table for this x1, x2 naught plus x3. So first I'm gonna need to negate x2, and then I need the connective x1 and x2 naught, and then the last one with an OR, the last two. These two columns, connect them with an or a plus. So let's finish up this table. So here are all possible inputs of x1, x2, x3. And now x2 naught, meaning we negate x2. And then I need x1, x2 naught. It's an AND, so I have false, true, true, and false, false, or 1 and zeros. And then for the connectives here, we have 0, 1, 0, 1, 1, 1, 0, and 1. We've seen this before. Networks and expression. So by combining AND, gate, OR gate, and inverter, we can construct a logic network representing a given Boolean expression that produces the same truth function that expressed. So this truth function that we've seen earlier, here is the Boolean expression for it. So the logic network for it will be, here is x1, the wire and then x2 we need to negate, and then between them what we need is an AND gate, and then you take x3 and connect it with an OR gate, and then the expression x1 x2 naught plus x3 is as output. So similarly we could do this, so you could stop the video and try constructing this logic network for this expression. So here we're gonna need x1 and x2 with an AND gate, and then we gonna need to take x3 with x1 x2 with an OR gate, and my result, it needs to be inverted because we have not. Then we can take x3, so again this is also x3, and we use another OR gate to combine all of them. So my output here is x1 x2 plus x3 not plus x3. So similarly here the question is asked, write the truth function and construct logic network with the AND OR inverter for each of these Boolean expressions. So take your time, write the truth function and the logic network. So right here we started with this table and all inputs. Now we're gonna need to negate x1 and then use the plus or between x1 not and x2, and then x1 not or x2 with x3. So the logic network will look like this. Similarly, we could try this second example. So as we see, we have this input because we have only x1 and x2. Then we need to negate x1 and AND between x1 not and x2, and then x1 x2. Then you negate the last column here, 1 1 1 0, and then you do an OR between this column and this one here, which is 1 1 1 0. And for the network, here is a network for this expression. And the next question, the logic network is given and the question is to write the Boolean expression. So obviously you negate x1, use an OR gate, and then you negate x3 and use an AND gate. And here is the Boolean expression for this logic network. I hope this video is helpful.